Hi, this is Tedeschi, CAD CAE Product Solution Evangelist with Autodesk's Manufacturing Industry Group. Today we're going to take a look at parametric optimization with Inventor Professional 2010. One of the problems facing designers and engineers using analysis software is frequently what to do and how best to deal with the stresses that are encountered during the use of that software. Fortunately, Inventor Professional 2010 has a full set of tools to help them do just that. We're going to start by copying this existing single-point simulation, Simulation 2, to a new simulation called, appropriately, Simulation 3. Now all we have to do at this point is change from single point to a parametric dimension or optimization design objective. Everything else we're going to leave exactly the same. Now you'll notice the advantage of copying an existing simulation is that all of our loads and our constraints are copied from the previous run, so we don't have to go through the task of setting up the analysis again. All we have to do is enter this parametric table builder and essentially show the parameters of the part that we wish to build iterations of. So we had high stresses in this tab, so what we're going to do is select an overall parameter that drives the tab thickness as well as a parameter that drives the rib thickness. Now these two parameters in combination should give us a good set of options and different configurations for dealing with those stresses. Now we're going to measure these iterations against the factor of safety, overall mass of the part, as well as the overall stresses of the same part. So we'll add all three of these design constraints. And you notice that we're selecting the body of the cover instead of the other part in the assembly because that really didn't show any stresses at all. Now at this point all we have to do is build the other thicknesses for these features that we want on our model. Now we can build a new configuration by simply sliding the slider bar there over to the side, and that'll build a version at 1.6 millimeters. But this would be impractical if we had, dozens of different configurations. So we can also, in a single click, we can generate a range of configurations for all of the different iterations. That'll take a moment, and once that's done, we're pretty much finished. Now we can basically scroll through all of the variables here, and you'll notice that in white, the wireframe shows the original version, whereas the light blue shows us the changed iteration. Now all that's left for us to do now is to literally just run the simulation. Now we can run either a smart set of configurations or an exhaustive set. Now what a smart set basically does is it interprets or interpolates the data, because this is a linear analysis, so it interpolates the data from the matrix itself. Now once we have our results, we essentially can just manually browse through the different versions and see how that affects stresses, mass, and in this case factor of safety. Now it's fairly easy when we're dealing with a model that has only 6 different iterations, but what if we had 30 or 40 or even 60? Now fortunately there's a tool to allow us to do just that. Now let's suppose that what's most important to us is the factor of safety. So we're going to say essentially that we want to avoid the range from 1 to 2.8. So as long as we're above 2.8, we're going to be good. So we'll set that. And now if we were building a sensitivity study to mass, we could say we want to minimize the mass, making sure we maintain that factor of safety, and we get the version that you see. Now similarly, we could build a sensitivity study for stresses with the lowest stresses, and obviously it's going to make the part as thick as possible. Now once we find the configuration that we want, we can simply grab that configuration and promote it back to Inventor. So these dimensional changes are now pushed back to the model itself in Inventor, and all of the associated parts and assemblies, drawings, etc. would all be updated.